Very good morning, student. Fourth lesson, next topic is power in AC circuit. Power in AC circuit. Introduction of power in AC circuit is power of a circuit is defined as the rate of consumption of electric energy in that circuit. Once again repeat, power of a circuit is defined as the rate of consumption of electric energy in that circuit. It is given by the product of the voltage and current. In an AC circuit, the voltage and current vary continuously with the time. Let us first calculate the power at an instant, and then it is averaged power averaged over a complete cycle. The alternating voltage and the alternating current in series inductive RLC circuit at an instant are given by, already we know the formula, V is equal to Vm sin omega t, I is equal to Im sin omega t plus phi, where phi is the phase angle between the V and I. The instantaneous power is then written as P is equal to Vi. So already we know the formula for the power is equal to product of the voltage and the current. Here V is nothing but V sin omega t, just substitute the value, V is equal to Vm sin omega t, then I is equal to Im sin omega t. We obtain Vm Im sin omega t plus phi. Here this is the formula for the sin A plus B. Sin A cos B, then cos A sin B. So substituting the formula for the sin omega t plus phi is similarly sin A plus B formula. So Vm Im sin omega t into sin omega t cos phi plus cos omega t sin phi, because sin A cos B plus cos A sin B. So multiple and simplify this equation, Vm Im into sin phi, this cos sin omega t multiple to the inner side, so we obtain cos phi sin square omega t plus sin omega t cos omega t sin phi. Here the average of sin square omega t over a cycle is 1 by 2, and that of sin omega t cos omega t is 0. Substituting these values, we obtained average power over a cycle. So here average of sin square omega t over a cycle is off, and that of sin omega t cos omega t is 0. Substituting these values, we obtained average power over a cycle is average power is equal to Vm Im cos phi into 1 by 2. Vm is nothing but Vm divided by root 2. Im is nothing but Im divided by root 2 into cos phi. That means Vrms into Irms into cos phi. Average power Vrms Irms into cos phi. Where Vrms Irms is called apparent power. Please note it down. Vrms Irms is called apparent power, and cos phi is power factor. Cos phi is power factor. The average power of an AC circuit is also known as the true power of the circuit. So once again repeat, average power of an AC circuit is also known as the true power of the circuit. Special cases. So this is a very important points. For a purely resistive circuit, the phase angle between the voltage and current is 0, and cos phi is equal to 1, because cos 0 degree is equal to 1. So average power is equal to, just substituting this value through this equation 4.55, we get average power is equal to Vrms Irms, because cos phi is equal to 1. Then second case is for a purely inductive or capacitive circuit, the phase angle is plus or minus pi by 2. And cos plus or minus pi by 2 is equal to 0, because cos 90 degree is 0. The average power is, just substituting this value, 0 into anything 0, average power is equal to 0. The third important case is for a series RLC circuit, the phase angle phi is equal to tan inverse of XL minus XC divided by R. The average power is equal to Vrms Irms cos phi. This is a formula, very important formula for your problem question. The next fourth important case is for a series RLC circuit in a resonance the phase angle is 0 and cos phi is equal to 1. So again the average power is equal to Vrms into Irms. The next topic, wattless current. Wattless current. Watt means power. Powerless current. Consider an AC circuit in which there is a phase angle of phi between Vrms and Irms, and voltage is assumed to be leading the current by phi, as shown in the phasor diagram. This is the phasor diagram for the current Irms and Vrms. Voltage root mean square, current root mean square. Angle between these two terms is represent phi. Here also phi. The first point is the component of current Irms cos phi, which is in phase with the voltage is called active component. So please note it down, children. The component of current Irms cos phi, which is in phase with the voltage is called active component. The power consumed by this current is equal to Vrms Irms, because already we know the formula for the power. Power is equal to VI Vrms into Irms into cos phi. So that it is also known as watt-full current. This condition is watt-full current. The second one is the other component Irms sin phi, which has a phase angle of pi by 2 with the voltage is called reactive component. This is reactive component. Here this is active component, this is reactive component. The power consumed is 0, hence it is also known as wattless current. So this is the wattless current. Once again repeat, the other component Irms sin phi, which has a phase angle of pi by 2 with the voltage is called a reactive component. The power consumed is 0, because cos 90 degree is nothing but 0. So 0 into anything 0. So that is a power consumed is 0. Hence it is also known as wattless current. That means powerless current. The current in this point is very very important point. Please note it down. The current in an AC circuit is said to be wattless current if the power consumed by it is 0. So wattless current means power consumed by it is 0. This wattless current occur in a purely inductive or capacitive circuit. Please note it down, children. Wattless current occur in a purely inductive or capacitive circuit. The next important topic is power factor. Power factor, this is a 2-mark as well as 3-mark question. The power factor of a circuit is defined as one of the following ways. There are 3 formulas. Power factor is equal to cos phi is equal to cosine of the angle of the lead or lag. Power factor is equal to formula is R by Z. That means resistance by impedance. Resistance by impedance. Power factors, another one formula, average power divided by Vrms into Irms. That means true power divided by apparent power. Some examples for power factors. First example, power factor is equal to cos 0 degree is equal to 1 for a pure resistive circuit, because the phase angle phi between voltage and current is 0. Then the power factor cos plus or minus pi by 2 means that is 0. Cos 90 degree is equal to 0 for a purely inductive or capacitive circuit, because the phase angle phi between voltage and current is plus or minus pi by 2. Then the last one is power factor lies between 0 to 1 for a circuit having RLC, that means resistance, inductance and capacitance is varying proportion. This point is very very important for your objective type question, then problem also. This formula also important. Please note it down, children. Advantages and disadvantages of AC over DC. There are many advantages and disadvantages of AC system over DC system. Advantages: the generation of AC is cheaper than that of DC. Generation of AC is cheaper than that of DC. First point. Second point is, when AC is supplied at higher voltage, the transmission losses are smaller compared to DC transmission. Third point is, AC can easily be converted into DC with the help of rectifiers. So AC can easily be converted into DC with the help of rectifiers. Then disadvantage is alternating voltage cannot be used for certain application such as charging of batteries, electroplating, electric traction, etc. Second point disadvantage is at high voltage it is more dangerous to work with AC than DC. So these two advantage and disadvantage for your 2 mark and as well as 3 mark question, children. Please note it down. Once again repeat advantages. The generation of AC is cheaper than that of DC. When AC is supplied at higher voltages, the transmission losses are small compared to DC transmission. Third point, AC can easily be converted into DC with the help of rectifiers. Then disadvantage is alternating voltage cannot be used for certain applications such as charging of batteries, electroplating and electric traction, etc. Then the last disadvantage is at high voltage it is more dangerous to work with AC than DC. Thank you.